Okay.
And I just started recording.
Okay.
I almost
Oh,
forgot.
Shannon, this looks really pretty.
Yeah, so like I have like a laptop. So again, my boyfriend's a lifesaver. He bought me this laptop for Christmas, and it's like the one where you can like draw on. So I've been like totally taking advantage and drawing like things on there, and it converts it to like these lines. So I'm obsessed. Like, just to even show you real quick, like I got to draw that. I was like, yes.
That's beautiful. So
Wow.
will you email this to us?
Yeah,
Or put
so
it in
I've
the
actually
drive?
already uploaded it to the share drive that Stuart had, but maybe people don't know it's on there. So I will email this to the group, and it's going to be uploaded and saved on there also.
Well, I had pulled it off the drive, but there weren't quite these new pictures when I.
Oh yeah, I just did this like 10 minutes ago. My boyfriend was showing me. He's helping me with this problem.
Beautiful.
Yeah. So yes, definitely we will get this on there. So I do have a note, or we left off on question number 18, and everyone was saying it was pretty straightforward. I struggled with it. So I again got help. But what my misunderstanding with this particular question was where to set up the obese categories and the race categories. So I kind of struggled with the order of that. And then I did figure out that this order was appropriate, but then I kind of, for example, for the probability of the randomly selected women in the town being obese, like I added these and I got it wrong the first time I did it, because it's not,
Yeah,
you're
'cause
not
it's
supposed
over
to add these.
100%.
Yeah,
Yeah.
you needed to add the
These.
probabilities. Yeah, I was about to say you had to add probabilities, and that's where you got your that's where you got the entire your population from,
Right.
like the last time. Yeah.
Yeah, so that's that concept. I'm still, very much struggling with that. So that's what we did here for probability of the randomly selected woman. You have to make sure you get, you go from the race. They outlined the race. They provided all the answers for this, and then they provided all the answers for those who were listed as obese. So then we calculated that. You just multiply the two based on his tree method, and then you get this. So that's the randomly selected woman in this town being obese. We just added those, and that matched up to the answer in the book. And then
I actually got that one, but I could not figure out B, C, and D.
Okay, so yes. So these, I also very much struggled with it. And as you can see, I took notes from where my boyfriend kind of helped me. He said that you have to utilize Bayes' theorem to do the remaining three, which I don't recall that was explicitly mentioned in our notes, but it lines up. So for these particular ones, we had to multiply, and this is actually going back to what Amanda taught us in the last session too. You actually have a new sample size. So I multiplied the race and the obesity for, like, if you're white, this is the probability that you're obese, multiplied those two numbers, and then divided it by our new sample size, which was this 0.371 of obese individuals. Or you could have just done like, this times this, and then that's how you got the answer. And that's going back to what Amanda said, because you create that new sample size because we now know how many in the town are obese. So I got stuck on that too, like again, and then went back to,
Okay.
Could we walk through, could you walk through that for me slightly more slowly on B?
Sure. So like, once you've done, and Amanda, step in, please, because you're like our genius on this call. But yeah, I just remembered it clicked when my boyfriend was showing me, because she's, in our last session, you're creating a new sample size because you have to calculate the new group that is considered obese, which we just calculated in the previous question. We got 0.371. So that's
Right.
the new population of people that are obese. So the question is, given that they're obese, which is now our new population, what is the probability that they're white? And so again, I got that wrong because I thought you could just take these numbers directly, which you can't take. You have to now take that number and then divide it, kind of get it out of your new sample size to get the percentage. So for us, we're now taking the probability that someone is white and obese is 0.158. and divided by that sample size, that's the answer for that one.
Okay.
So essentially what you're doing is actually you're working backwards. So these questions, they're wanting you to know who is obese and what is the probability. So in the beginning, they gave you from the race if they're obese or not. So now the questions are reversed. They want you to find out the opposite. So if obese, then are they Hispanic, Black, Asian? So that's why you're having to take the new, so you take the new, so you take your new sample size, which is our first question there, and you have to divide it by whether or not she would be white or Black. It's like working in reverse.
Yep.
So
No,
Mitch,
that makes sense.
is this where it would be, if it was written out, it would be like white given that she's obese, where it'd have the little line in it, so the formula would look like it was white and obese divided by obese, essentially?
The way you find, if you have to use this theorem, well, they call it a theorem. If you have to use what I like to call the reversal, you'll have, so they'll go in the question, they'll give you this because this, okay? So you're looking for questions that give you a percentage of people, but also give you, out of those people, this percentage of stuff happens. And then in the questions, you look for, they say, if the second clause, then what is the probability of them being the first clause? You get me? So you're
Okay.
looking for the opposite, which is why I like to call it the reverse probability.
Thank you.
There is also a quick, I don't think I'm smoking here. I think there was a quick lesson on Bayes' theorem. I think it's one of his videos.
One of the
It
YouTube
is.
videos.
Okay, all right.
Yeah.
Okay, yeah, YouTube video. Sorry, never mind.
It was like his second video because I just watched them all.
Oh, yeah, I watched them the first day. So I, because it all went a blur, I'm like, what was in it?
I got much more out of him after our first study session. I was
Mm.
kind of like Amanda. I was watching him today. I was like, oh, okay.
They
Yeah,
made
I
a
get
lot more
that now.
sense after
Yeah.
our study session rather than before.
That's a good point. I think I might go back and watch them again. Because it's like, yeah, it's learning this. And then my boyfriend's mean. He's like, you got to calculate it yourself, figure it out. So he's doing it to force me to learn it. So I'm like, okay.
Well, the nice part about the book is that it actually teaches you how to do these things in Excel. And I find that really helpful because I've never done these things in Excel. I've always done them on calculations, doing the theorem, doing the hand calculation stuff.
Right.
So it's really neat.
Yeah, it is neat to do it in Excel. I think it's easier. And for me, sometimes I get mixed up crunching the numbers in a calculator. So for having it available in Excel is a lot easier for me, at least. So that's how we got the answers for these. Again, the same thing. I outlined kind of that, but it's pretty much the same as this. You'll get the same answers if you just take the number that you just calculated in the previous area. So that should be the answer there. We hit save on this. Oh no. And I'll do this. Okay. Any questions on this one before we move on? I did not do 4-3, so we'll have to work on scratch from that. But any questions on this one before we move on?
No, that makes sense too. It's this, the rest of them are the same.
Right, it's the same
BC
exact
and D.
calculation.
Shannon, I'm not, just so you know, when we're done tonight, if you're willing,
Mhm.
it would be awesome if you could re-upload this. I'm not seeing the one from a few minutes ago.
Oh,
The
yeah,
last one I'm seeing is
Yeah,
from
you're seeing the last
Thursday.
one because this one I literally just did this like 30 minutes ago.
You're awesome. No
So
worries
yes,
at all.
I will upload it.
Thanks.
In fact, I might do that real quick, just in case you guys can just take notes on it real quick. Or maybe I'll just do it after.
No, do it after. Do it
Yeah.
after.
Okay. So now moving on to these, this one I did not start on, but I do know, I did watch the lectures on this, and he does do the same, very similar tree format for this part. So maybe we could all start on it together.
Sounds good.
Yeah,
Because that for me is setting it up. Try
Yeah,
which
it's
way do we
that
set it up. That's what I
shorter.
mean. And now we're talking about, that's what I was struggling with. So if we're setting it up together, that will help reinforce it.
Yeah. Okay, so I'm gonna. Okay, so for these, I'm gonna have to do this anyway. Okay. So an appliance store sells additional warranties on its refrigerators, and 20% of the buyers buy the limited warranty. I'm just writing what we know.
Mhm. Then extended warranty.
extended warranty and then no warranty.
Mm-hmm.
It's 5%, right?
Mm-hmm.
Yes.
And then no warranty. Fund. Okay. Okay.
Mm-hmm.
That's like me. I never buy the warranty. Oh gosh. All right. So, refrigerators. Okay, so 20% buy it, 5% buy the extended. And then what is the expected revenue for the store if the warrant from the warranty if it sells 120 refrigerators? Eek. All right.
Okay, do you know where to go from here?
No.
Oh, so what I
Okay.
did was by limited warranty, I put the $100 revenue.
Oh,
And then by the extended warranty, I did $200.
Right.
And then no warranty, 0. And then
Right.
I multiply the revenue times the probability.
okay.
That gives you that's what we call the mean.
Mm.
Now you have the mean of what happens whenever people buy the warranty, right? They can get, when you add all that together, that becomes the mean. So what you do with it is you multiply it by 120. Because that's how many refrigerators we're hoping to sell.
Mm-hmm.
And then that should be the answer.
This becomes the mean.
Yes, that's the mean of the actual group. So it's essentially, it's the mean of the probability of what could happen, right?
Yeah, no, yeah, it's exactly what it is. So for one customer, on average, they're gonna make $30 of warranty stuff,
Correct.
regardless of whether or not the person doesn't buy anything or they buy everything. This was like in some other class we have where they were talking about, the answer doesn't necessarily make sense, but it's part of the bigger answer, I suppose. So yeah, so then 30 times 120 would be the probable revenue, the expected revenue or the projected revenue based on those probability amounts.
Mm-hmm. That's absolutely correct.
Mm-hmm.
It's weird to me because this one is simple enough that I wasn't even looking at it as I did it this way, but I wasn't looking at it as a probability question. This is more like a mathematical question. This is just like an algebraic, an expression and solve it.
Right. And
But that's
why I
okay.
say when we go into this side, so we go into 4.3 and 4.5, it really turns more towards math rather than
Yes.
towards the tree. So I
Yes.
understand he does it with a tree, but in this reality, it's just easier to have a table
Mhm.
Although I
rather than
would
a
say,
tree.
yeah, I totally agree with you. I do think there's two things there. So when he was stressing the tree, he's right about the comment about work, right? Our bosses are going to want to see a tree.
Mhm.
The other part is,
Yeah.
it seems like the questions that are going to be on the quiz are all apparently conducive to trees. I'm gonna let it go at that. That's based on what he said. So I'm not saying we don't need to know the other way. But
Oh,
looking at
agreed.
this, and honestly, looking at this question as kind of this probability aspect of it is kind of insightful, because I normally would never have even approached it this way. I would have approached it as a traditional word problem and just solved it. So it's kind of neat. I'm gonna hush up. Let's do 28.
Hmm. So I'm like,
So
I guess would you approach it the same way with that?
yeah, so
Yeah.
I would do let's do the employee ranks first. So let's do A, B, C, and D. I think one of the examples did like excellent, good, fair, and poor. You could do that
Yeah.
too, but whatever.
Yep, superior or something.
Yeah, whatever. That'll work.
It don't matter.
Fair and poor, good. And so you got 15%, 30%, 10%, and whatever the difference is. Those are what they're getting. I put that first. Maybe I shouldn't have, but I did.
In this particular one, I don't think it matters which way is first.
Which way, yeah.
It's gonna be the same.
15, 30, 10, and 0. Well, oh, wait.
Is that wrong?
No, yeah, no, but hold on. No, that's correct. Sorry.
Okay.
And so now we could look at the bonus amounts. So the 15% get 20 grand,
Mhm.
then 10 grand, then 5 grand, then 0. This is really the same exact question as the one above it.
Yes, and you're correct. It is actually the exact same as the one above it, so. You solve it the same way.
Oh, so we just do this times this,
Mhm.
and then
Yep,
sum it up. Okay. And then this is the mean of the
That's
salary.
the mean of the probability of the salaries, because this is a plan.
for the bonus.
Yeah, or a bonus, so yeah, whatever. It's just, I mean, it's still the probability of the mean is what I would call it.
So that basically says that for every employee, it's gonna cost 6,500 bucks.
Correct.
No, wait, that's not the mean though. Wait, is it?
That's
That's
the
the
mean.
sum.
That,
That's right. That's right. Sorry, I'm so sorry. Yeah.
I'm
So
like,
then,
no, it's still correct as far
Yeah,
as I
no.
know. Then you have to multiply it by your quantity that you want to find out.
Which is 200.
Yep.
Mhm, 200. And then projected bonus details. That would be equal to this times 200.
Yep,
Oh, that's nice.
That's exactly it.
That's why they want more people, 45% get rated poor, so they don't have to pay.
Right. They don't want
absolutely.
to pay out the money, but yeah, that's essentially why a lot of people don't get paid a lot.
Right. Okay, so I get that's really straightforward. It doesn't even seem like it's probability. Like it just seems like straightforward. So
So
thank
we like
you.
those two problems.
The mean, the probability of the mean is actually probably one of the easier things to pick up because it's just like a normal mean. You just have to multiply the probability of what will happen.
Okay, which is the percentage that they've outlined.
Correct.
Okay, got that. Okay, does everyone understand that? And I move on to the next question.
Yep.
So we'll probably set this one up the same way. Okay, so economy will improve. Oh. will improve. Will stay the same. Okay. So 0.30, 0.40.
0.30.
Oh, thank you, 0.30. And then, so if it improves, it's 15,000.
Mhm.
Can also stay the same.
10,000.
8,000. Okay.
We want to put the 8,000 is a deterior.
Oh, so it should be negative.
No, it's actually not a negative. It's a
Yeah.
positive. It just goes down to 8,000, not to negative 8,000.
Oh,
Lose
goes down.
$8,000. He
Yeah.
loses about
Oh.
$2,000.
Oh, I'm so sorry. Okay, never mind. I apologize.
So that, let's do this. Okay, so this is the same thing. This is the mean of the probability of stock market earnings.
I don't think so, right?
Actually,
Well, yeah.
amazingly enough, in this case, I do actually believe that that is the expected value of his investment because we're not
Yeah,
giving.
I think so.
So
Okay.
that's actually the answer that they want you to find, I believe. You might have to check me. I don't know. I don't have the answers in front of me.
Yeah, that
should
is the
duly be
answer.
correct.
That is the answer.
Yeah.
That's what I thought. Because I was like,
Oh, wow.
yeah, that's the actual answer. They want to just know that.
Awesome. So that's that. That's the answer. Okay.
Yeah, that's it. It's a really easy one. You don't have to multiply it by anything. You just have to realize
Another-
that when you're doing this kind of
Mm.
problem, don't be surprised that when they ask you for time value of money, it's actually just the probability of what will happen.
Okay.
Perfect, perfect. So if this was the same question, but instead of it just being this dude investing 10 grand, let's say this dude was an investment agent and he was going to invest 10 grand of 10 clients. So in other words, 100 grand. If we wanted to see that, then that might be that next step. Although again, it would just be, times 10. So, all right, cool.
As long as they give you as long as you that with this one, it's tricky because it's involving money and percentiles. Be
Mhm.
very careful with those because sometimes they will try to trip you up, but
Okay.
oftentimes that is what you do. You go for the mean of the probability.
Okay. Okay, so we have the answers. Thank you all for those. And I understand it. I mean, like I said, these seem pretty straightforward once you read through it, like the word problem. So any questions on this before we move on? Anyone else? Okay, hit save. Right, so now we go into section 4.5. I only did 52, so I didn't get through the other two.
And you did that on your laptop?
Yeah, like on my, it's like the laptop that has like the touch screen. It's
Yeah.
the Surface Pro, so like I could draw on it. So I was like, oh,
With
that's easy.
stylus action.
Yeah,
That's very
nice.
cool.
I love it. I was like, and this thing is not needed, but I told you my boyfriend was like, you got to figure it out yourself. So I was like, that's the way he showed me how to do it. So for me, I recreated it because that's how I understand it. Is that this one I struggled with, like, still, and we've been learning this since last year, and I still struggle with standard deviation. So I'll explain what I know, and then anyone can jump in. So for this part, the professional basketball team averages 105 points per game with a standard deviation of 10 points. And the key here is to know that it follows a normal distribution, which I'll highlight. So because it's normal, we know that we can use this curve and that the average is going to be in the middle of that curve. So that's why we put the 105, which is the average of the that we have here as far as data. We can put that in the middle of our curve. And so they're looking for the probability that a game score is between 85 and 125 points. So we know the standard deviation is 10. We're just going to factor into our formula. And we know that we're looking for our X value between 85 and 125 points. And between 85 points, the number of probability is going to be everything from 85, like all the way down to 0. So like this little section of the chart. And then everything that's 125 points is going to be this section of this chart, the whole thing. So because of that, we want to know basically between 85 and 125. So we would have to take the probability or normal, I'm just going to cheat, normal distribution number here. Just the difference between the two is going to give us what's in between here in this little chart here. So that's all I did. Same thing here. So we wanted the probability that it's less than or equal to 85, which was like this part of the curve. And I plugged it into this formula. And that's why I thought it was important to map out like what your number, like what numbers you knew. So you're like your average, you have your standard deviation and your number. And then you're going to say that it's true. And again, we know that it's a normal distribution. Now this we learned in our last class. So this part I actually kind of remembered because I knew that we learned this in our last class, how to do it this way. And I did the same thing for the 125. So to get the score that's in between the two, you just subtract the two. We got 0.9545.
The interesting thing on this one is we're dealing with two standard deviations, right? Because the mean is 105. And one standard deviation is 10. So two standard deviations, which is 95.45 by definition.
Oh, yeah.
So
Is
that way you can
85.
just see, right? You could just see that and do it pen and paper because it was even
Yeah.
numbers, right? So you don't.
Yeah, this one, I think this one's intentionally easy. My instinct, I hope I'm right, is it will be very similar to the one we see on the quiz.
Oh,
I don't, but you just proved it, right? So this is great. So and then basically the rest of it, and so the question is what's the likelihood that they're going to be more than 125 is outside, you're right, two deviations on the upper tail. So and that looks right. Just the result, I mean, the calculation is right. And that number is intuitively right because I would have taken 1.0 minus 0.9545 divided by 2. I don't know if that comes out exactly the same, but I'm a little curious, actually.
so what is it? 1 times what? Oh, times this value?
It's 1 minus that. 1 minus that divided by 2.
Okay. Yeah.
There you are. Yeah.
Yeah, so there's 2 ways to calculate it then, because I did the same thing. It was 1 and then times the normal distribution, which you're right, it's exactly the same numbers we
Well, we
pulled
know
up
we
from-
have the right answer.
I think you're
then,
better
so that's
off
good.
not. I agree that it's awesome that this one did end up that way, but you're better off keeping to the other formula just because not all of them will appear like that.
No, I think we're going to get one that appears like this. And the question is, Amanda, you're right. We need to know the math behind it. I'm not arguing that. But I think in terms of the quiz, the first thing is to look at the mean and then look at the standard deviation calculation and where the numbers are that they're asking for. And there is a chance, I think, for the quiz that they might line up. I think the next one will probably be, it's the same kind of question, I think. I'm assuming it's not going to be quite as convenient, so we could go
Yeah.
down there.
Agree.
Cool deal.
This one, there is a second part to the question. If there are 82 games in a regular season, how many games will the team score more than 125 points? So the logic behind this is if for one game, the probability is going to be 200 point, 02275. For 82, like from elementary school, they taught us like the proportion stuff. Like that's how I visualized it. So if it's going to be 1 equals this, then 82 games would just be multiplying these two numbers, and that's how we got 1.865511
Mm-hmm.
was the answer for that one for 82 games.
That sounds about right. Yeah. Be roughly one.
Yeah.
One
And
or
that
two.
answer was in the textbook. They said they phrased it as approximately 2, and they showed the 82 times the 0.02275. I just didn't understand why they did that. So that's why I put it in this like proportion format. And then I was like, oh, okay, that makes sense. So, all right. So I'm going to move on. Any questions on that before we move on to the next one? Okay, so I'm going to just go to the next question here, 54. So I always start out with typing out what we know. So this is a normally distributed random variable. So it's a normal distribution. So we know we can follow the same thing with a mean of 33. I'm gonna kind of just copy this stuff here. The mean is 33.8 and the standard deviation is 3.5. So what is the probability that a randomly selected passenger car gets at least 40 miles per gallon? So that's one of our variables there. Looks like we have 2 more based on what you've seen. So we'll start out with the 40. And I would do the same formula, which for me, I'm just gonna, I can just do normal distribution. So this, and this one I haven't looked at, so I'm just doing it from what I think it's supposed to be. So stop me if it looks wrong. So our X value in this question is this. Our standard deviation is 3.5. Our mean is this. And this has to be true. So that's the answer we got for that one. Does that match? Look at the book. Wait for that to load. And then the next one between 30 and 35, it would be the same thing. We want to calculate the 30 and the 35 so we can kind of get the answers for the two. So I'll just do probability. Probability that it's less than 30. And then the probability that it's less than 35. So it would be the same type of calculation. Mean this. True. So between would be I'm assuming these are the answers for that. I'm going to look real quick. Does anyone know? Did anyone do this?
I think the top one is because you're greater than 40. If you look at the thing from the top, the previous question where you have 125, you're looking at it that direction. So it's 1 minus that.
Ah, thank you.
Yeah. I was gonna say 40 is actually counterintuitive that it would be 85% if the average is 33.8.
And
That's the other thing I would recommend is when you're looking at these numbers, ask yourself if if they're reasonable.
So
Does that make sense, Shannon?
No, so this one I got wrong. So is it, it's
That
like
one ain't
1
right either.
minus, is it? I see what you're saying because the formula is saying that at least 40, right? That's what the key word is on here, and at least.
Yeah,
So it would be
Mean
like
is-
40 or more.
Yep.
yeah.
Oh, so then it would be 1 minus. Oh, so why is the formula not working? Did I do it wrong? Mean
Mm,
is, oh, yep, I did. It's reversed. The formula, the mean is this. And then the standard deviation's this. That's why.
there it is.
Much better. That's it.
There we go.
Thank you so much, Anthony.
You're welcome.
Check that out.
I
So
think
that-
on his test, he's probably going to have 4 answers. You're going to get multiple choice. So if you get something that looks funny, you can,
Yeah.
you got
Redo.
enough time, you could go through the other 3 answers and see if it's a better fit.
Right. Right.
Oh, actually, hang on. I was going to ask that question. Is this actually a multiple guess quiz, or is this like one where he gives us the questions, we do them on Excel and upload it?
So he did say that the answers would be there, you just had to figure them out. He did say it was multiple choice.
Huh, okay.
Yeah, I think it's multiple choice as well, because he never
My
said it.
stress level,
No way is he going to go through 100 and something Excel sheets and grade a quiz. Come on.
Right.
well, I agree with you, except he's doing that now, right?
That's true.
With the
Yeah. he
homework
did that for the last
assignments.
two.
You know,
Yeah.
and but I'm not arguing that. I mean, my anxiety about this is dropping precipitously. So that's, thank God, and I hope everybody's is the same. So is doing the same.
Yeah.
So good.
Okay, so we've gotten that answer, and then the other answer for between 30 and 35 matches the book 54. So 0.4952. Yep, it's the same. It's just the rounding. Okay, so I'm not gonna look. I'm curious how you all would approach the third question. Let me bold this real quick because that's like our key.
So that's 3 deviations.
Okay, so would it be 3.5 times 3? And then you just, oh, I know, I'm lost. So it's 3 deviations because it's 99%.
Well, I'm looking at the answer here. Does this have anything to do with that lookup in the Z-score or the, hang on a
Yep.
second. That's what I
Probably
thought.
does, but
Yep.
it's normally distributed, but the last one, I think. Oh,
I
yeah, because
watched-
improves upon 99%. Yeah, that's the Z that tells you which column to look at.
Okay. So our Z
Um,
table,
Let me see if I can get my Z table up here. Hang on. There it is.
0.99, I think it's 2.33.
I'm gonna look
having-
too, 'cause I don't know where I would get
It's
that.
Appendix D.
Yeah, it's Appendix D. It's the
629.
first table. It's
Appendix
2
D.
pages. One side is negative, one side is positive.
Okay. Where is that in here? Does anyone know like the quick? Oh no, I'm way behind.
Page 6.
Page 631, I think.
631. Oh, it's different. Okay.
No. Go, it's page 994. There we go.
Okay, thank you. Okay, so here we go. Here's the Z table. Okay, I'm gonna put it here. Look at it. Okay, so we know it's 99%.
You want the
What's
other one.
missing
You want the
from
other
We want the
page,
other
not
Z
the negative,
table.
not the positive one.
That one right there.
Oh, yeah, the positive one.
Oh, how do you know that? Sorry, that's a dumb question.
It's not a dumb question because
Not
you're
a dumb question.
Not a
You
dumb
won't-
question.
So you're looking at, instead of like where in his videos where he says find the z-score,
Yeah,
and then like he says, say the z-score was 1.15, right?
right.
So you would find 1.1, and then you would go across to 0.05, and you would be at 0.849. In
Okay.
this question, you have to look for the 0.99 in the table, which is down around 2.3 of
Oh, yeah, so it's like
0.2 and
backwards.
0.3.
So that is, if I'm looking, it would be, let me find it. 0.99 is where?
Keep
99.
going. Go back up
There,
at 2.3
Right
right
there.
there. And it's between 0.02 and 0.03. No,
Oh,
no,
the other
the
one.
other way.
So it would be between here.
yeah,
Right here?
0.9898
Yep,
and
between there, those
0.9901.
two.
Oh, so if it's not exact, it's whatever's in between the two. Okay.
Well, they went and took it to the extreme and figured it out. If you round it up to 0.233, that's probably the answer you're going to get, it's closest to whatever he's given.
Okay, I'm writing that down. So
You understand it or no?
Well,
No,
How did we know that it's in the table versus going on that first column 0.9 and then going over to 0.9?
Because
That-
there's a formula, which is the mean plus the z-score times the standard deviation.
Hmm. What formula is that?
It's manipulated from the other one,
It's right,
where it's
if
the
you could
mean minus the standard deviation over, or no, the mean, the
plus,
I forget.
I think it's the mean plus the standard deviation times the z-score.
Mean plus.
Here, Shannon, go down in the book, go down to page 1005,
Okay.
and you'll see the 4.54 part C. Right there. See that 2.326 is what we just calculated off the Z table.
2.326. All right, I'm just putting the answers here. Sorry, because going back.
No, it's perfect.
No, that's the perfect way to do it, because I guarantee you somebody will be looking for it.
Yeah, because he's searching. I'm like, it's 10 different screens. How did you all get the 2.326? Is it
Yeah,
because
so if you look at the yellow ones in the chart, in the Z lookup table that you highlighted, so to the left, in the blue column is 2.3, and then move back to the two columns and go up to the top, and it's 2.32 or 2.33.
Depending on
got
however
two-
you see it.
Yeah, and how you round it. And they got 2.326, which is kind of right in the middle, times the standard deviation.
so 2.32 is because this lands here,
Right.
and 2.33 is because this lands
Yep.
here.
Yep.
But how did you get 2.36?
What
Oh,
they did
oh,
is
it's
they took the
2.36.
difference of them.
Hmm.
I think it's they got 2.326.
Yeah, 2.326. Where's that?
You would have to take the difference of the two scores, like what is
Oh,
that,
that's correct.
9898? I gotta
Okay.
remember how to do it.
Yeah, I'm remembering that now. You like somehow,
Two. And
you
2.
average them?
I think you gotta divide it by 2 or something. Take the difference and divide it by 2. Can't remember.
I can't either.
I'm
It's
gonna
in
try
the
some.
video. I mean, it's in his video. A little, I think he goes into it a bit there. Yeah, the camera will go away.
Well, to get it close, I mean, the average of the two of 2.32 and 2.33 is 3.25. Need format. I'm gonna
Oh
see
no,
if
I was talking about the score. It's the percentage itself.
the percentage.
The
0.9901 minus 0.89898 divided by 2, but I can't remember.
This.
No, that's not even close.
no.
You said it's in the lecture. I'll have to go back. That's gonna kill
It
me.
is. He deals with the Z-score stuff there.
Okay.
He does.
Okay.
What I have.
But did you all
I
calculate it?
use 2.33 and it
2.
gets you close.
Okay.
What I get.
Maybe
I
that's
had
what we do, because the
41.955. So that's as close as you're gonna get to the answer.
Okay. Yeah, if you use that.
With it being multiple guests, we'll be able to. They're not gonna make that be a problem because, yeah, I think that's correct.
Boy, it didn't like that.
Yeah, I didn't like that. You can do it like this. What's this?
Put
Oh,
A
yeah.
put A in parentheses.
Yeah, that's
There
what
you
it
go.
is. Yeah,
Try
thank
that.
you.
There you go.
Yeah, so it's it's really close, really close. So as long as we get an answer between the two, we should feel comfortable using it. I'll calculate it under both. That makes sense.
Well,
I think
the
I'll-
other reason I have a little bit of difficulty with that is that wouldn't you follow the Z-score that's closest to 98? So you're going for 99%, but that's going to be in your one percentile though, isn't it?
Yeah, but well, 0.9901 is much closer than 0.9898 to 99%.
I got you.
Right?
Okay. Yeah.
I might be
was
wrong. I
just-
think I'm right. I know I am right. It's half the distance.
So choose the closest Z score. Okay.
And then
But with that logic, it would still be 2.3, wouldn't it? Because look at
Yeah.
where it is on the graph that you highlighted.
I believe so.
So it would never be 2.32. I'm just pointing it out that, you know, you
Well,
found
see
the
what it is.
closest
Yeah,
Z-score.
no. I mean, let's see what it is at 2. Well, what's driving us is that the answer in the book is, we're kind of curious about it, right? So what if we just calculated that out with 2.33?
We just did, like we calculated it
Yeah,
out.
she did
both.
232
Yeah,
or
that's what we
233.
would do. Yeah.
Oh, I see what you did. Okay, never mind. I gotcha.
Yeah,
I
and what
gotcha, I
Anthony
gotcha, I
was saying,
gotcha.
the closest, he used this one because it was closest and it's only like one off.
I was
Versus
reading the graph wrong. Sorry.
Oh.
I just realized what I did wrong. I was like, oh, okay, you did it right. No,
If you're
good.
not used to reading this table, you can get lost real
Yeah.
quick.
It's been a hot minute since I've seen one of these tables.
Yeah,
Hey,
I threw my
Shannon.
table away, so.
I'm
like,
putting I'm putting in a quick note on calculating Z-score in Excel. It's like a link to an external page. I don't think you need to bring it up, but you could maybe add it to the notes
I'll
for
add it to
folks.
the notes. Thank you very much. Okay.
Oh, I see what they did. Yeah, they really cooked it out. That's fine.
Okay. All right. I'm good with this just because of you all helping with that table. I didn't understand it. And there was also that formula which they showed in the answer. So if that's a standardized formula and we know to use it, then I'm good. So
Well, it's manipulated from the formula that you use, like when you're taking your data point minus the mean
Yep.
and then dividing it by the standard deviation. So it's just a variation of that formula. That's all they did.
okay. Okay.
I hate when teachers do stuff like that. Because you spend more time trying to figure out how to manipulate the formula than getting the answer.
Yeah.
Exactly. Yeah. Always makes me mad.
Never straightforward.
Mm-mm.
So everyone good to move on to the next one?
Playing from Jody Ann's iPhone.
I don't think I'm gonna have enough time to do the next one, but I do wish you guys all the luck.
Yes. Thank you,
Thank you.
Amanda.
You'll
Thanks
have
for your
it.
help,
Thank you, Amanda.
Really
Thanks,
appreciate it.
Amanda.
No worries, but I mean, this is not a bad spot for me to leave you guys anyway, because I'm not that good at these kinds of problems.
Thanks
So
for your
we'll
help.
upload this at the end. So we'll be uploaded on that SharePoint that Stu created. So we'll have that on there.
Perfect. I'll take a look
Alright,
at it in the
great.
morning. Thank you guys. Have a good
Welcome.
evening.
Sure thing.
Bye.
Thanks
Take
for
care.
your
You
help,
too.
Amanda.
Good one.
Great. So everyone else, are we all good?
Good.
Yes.
Move on. Okay. All right, on average, so this one, on average, an American professional football player, football game lasts about 3 hours. Even though the ball is actually in play for only 11 minutes. I know that so much because my son loves football and I can, yeah, this is true. So assume that the game time is normally distributed with a standard deviation of 0.4 hours. So let's see. So the game duration is what we know, and we know that that's 3 hours. And then the standard deviation is 0.4. So find the probability that a game lasts less than 2.5 hours. Okay. Okay, so I'm going to do it the same exact way we've been doing it. So this one, it would be 2.5 as our, like what we're looking for. And they said it was normally distributed or distributed. So we do this times this time when we do it right, the mean. And then the standard deviation. And it's supposed to be true if we're using the Excel formula. Oh, wait, let me make sure I'm reading it right. Less than 24 hours.
No,
What? No, ooh, no.
no, less than 2.5 hours.
Oh, less than 2.5. Yes, thank you. So less than 2.5. So it's still this formula. We don't have to do the 1 minus because it's
No, you're
less,
good.
right? Okay, good.
You're good.
Good with this one. And then the other variable they talk about is 3.5. So this one's interesting. It says find the probability that a game lasts either less than 2.5 hours, which we just calculated, or more than 3.5. So if it's more
Then
than
actually,
5,
this is interesting because so 2.5 and 3.5 are both 0.5 distance away on either side of the average. So think about that because it's going to be the same number.
but negative? Or no?
Well,
No,
no. So the P game lasts less than 2.5 hours is 0.10. It's going to be the same thing for games that last over 3.5 hours. So in other words, if you did the distribution like you did there in row 35 for ones under 2.5 and do it for ones over 3.5, it should be the same. Let's try it. Because they're the same distance from the mean. And you already calculated the probability for the low end. Now let's calculate the probability for the high end. And here's where we might need to do that 1 minus thing, but we'll see.
So this would be the 1 minus the norm distribution of X in this.
Wait. Go back. Standard deviation. The X is
3.5.
Mean, bear with me, mean is 3. C35 standard. I'm sorry, go on.
Oh yeah, that's okay.
Yeah, see?
Yep.
Wow.
So then all you have to do there is like double it, right?
Yep.
Why do you have to double it?
You're
Well, the
adding one side of the graph to the other.
Oh,
This is
you
where
get it.
that
understand?
picture helps. Yeah, this is where making the picture, the visual would help explain it.
Let's calculate it. Okay, so I can draw this out
Right.
and that
Or
will
you
help.
could copy that.
Yeah, let me copy this. And copy.
And just
Hopefully
change
it
it.
copies the picture too. Yay, it got me the picture. All right, so the numbers here would be the average is 3.
3,
This would be
2.5, 2.5.
And the 125 becomes 3.5.
Oh, because that's after the mean. Okay.
Yeah,
Well,
so
you're
you're
after
adding the left.
your line by like 35. You calculated 35 out to 1 and then 0.25 back to 0. And they want to know those totals, so you're adding them together.
Ah, I got you. So we're adding
And
like this and
Yeah.
this.
Yep.
And this is why it's important, just like in not the previous one we just did, but the one before it, where the standard deviation fit very nicely. It was like the same distance as what they were asking for. 2 of them were. But this is the same kind of thing where when you look at it and you're like, okay, the high end figure and the low end figure are identical distance from the mean. So you're calculating probabilities really for both sides as soon as you do one side, because they're mirror images of each other.
But
Does
that's
that make
only
sense?
because the numbers matched up in this case. Like it won't
Right,
always do
right,
that.
right.
Okay.
So look for the numbers is the key, because it'll save time. If you could see the
Oh.
pattern, you'll save time with your work. It's just a good discount double check too, because
Yeah.
even if you do it the long way, you could still do it the short way. Yeah.
Yeah. I get it now. Like visually, it makes sense because we got that side and that side, and now we're trying to figure out, either which side is better. So that would add the 2. So then the answer for that, the probability that a game lasts this would be is this plus this. So that's the answer,
That's the answer.
right? Yes.
Bing.
You all are the best. Oh my
No,
goodness.
this was awesome. I mean, this was pretty timely and it's helped me tremendously just being
Yeah.
able to talk through these with everybody. Anthony, thanks so much for joining us this evening.
Yeah,
too.
Anthony, for real. Thank
Well, just so you all know, I'm a data science student. I'm not a business student. This is an elective for me.
Oh.
I love it.
And they tried to keep me out of it.
Really?
Yeah, I asked when I registered I asked for it and they said, "Oh, no, we're holding it for MBA students." And I was like, "Okay." And then 2 days before school starts, they canceled one of my classes, and I went back to my counselor and said, "Hey, there's 10 spots left in that class. Can I get in?"
Right.
Good.
Yeah.
We appreciate your expertise for sure, because I
Yeah,
wouldn't
for
say
But
that
sure.
what happens with when you take data science, most of my class is theory. I don't see any practical application at all. So now,
Oh,
like with this,
this bridges
I
it.
kind of want to be in business analytics, so I kind of see how all this ties together now.
Yeah.
Nice.
Very cool.
We
That's
definitely
So
benefited
somebody was
from
asking
knowledge.
last week or the week before, not last session, but the session before, about how we get PCA and K-means. Well, both of them are algorithms written by a scientist back in 1967.
Wow.
Oh, wow. Huh.
Yeah,
So
that's interesting.
the solver and the mining thing come from a company called SAS, Statistical Analytics
Yep.
Software, which is
Mhm.
expensive as all get out. That's why the book gives you the option to do R, because R is open source
Yeah.
and anyone can download it.
Oh,
But it takes time to learn how to code.
Anthony,
Yeah.
are you doing R right now?
Yep.
Yeah, it's a big thing. It's a big rage at the university University of Florida right now.
Well,
If
the
anyone's-
reason that everybody's switching to R is because Excel can't handle 10 million data points.
Right.
Right.
After about a half a million, Excel starts crashing.
Mm-hmm.
So this software can handle more, and there's other things out there that can handle more. So just something for y'all to be aware of, even though he's only like scratching the surface of all this. The
Yeah,
more
yeah.
data we get into in years to come, you'll have to keep up with the technology to be able to handle all of it.
Yeah. No,
If you're
that's
actually
very useful
doing
to
the
me.
data massaging, yeah, absolutely. So two things. If anyone is interested in R, that we've got an online self-paced course at UF that's I could get you guys in for free. So let me know. Just shoot me an email or something offline. And then Anthony, I was going to ask, like, where are you physically located if you're willing to share?
I'm in Marianna, Florida, and I work in Tallahassee for General Dynamics Land Systems.
Very cool.
Oh, very cool.
But
Nice.
I'm an engineering tech. I basically test equipment and diag and troubleshoot. But this is kind of like it's kind of like on the same thing. It's just solving different problems. So I'm trying to switch careers.
Oh,
Okay.
okay. Yeah. No, we
So-
have people that do that. I work for L3 Harris, and it's not the same, but very similar,
Very,
type
very
work.
similar. I know
Yeah.
who L3 is.
Yeah, so I do the HR stuff. My boyfriend works, like, he's a software engineer in cyber, so he knows like that world. But we hire a lot of you guys, so if you ever need a switch.
Hey, so listen really
Yeah.
quick on and Anthony, you're gonna have a world of opportunity once you're done with that. I'll just say that now.
For real.
Well, I'm already getting people that are asking
sure
for me
you
to
are.
internship and everything else.
Yep.
I only got 4 classes to go. I'm done.
Excellent.
Wow, that's awesome.
Congrats, man. That's exciting.
Yeah.
The other thing, keep an eye out for now that the world is opening back up again a bit. There's this big health information management. There's this professional group. The acronym is called HIMSS, HIMSS. So they're having their big conference down in Orlando in March.
Okay.
And this is normally like, I don't know, it's like $1,300 and something to go. It's a week. It is one of the coolest things ever. But I was looking at it this past week because I was like, hey, I wonder if I should go to HIMSS. And I don't have any money budgeted this year because of the pandemic for that
Yeah.
kind of event. Well, check it out. As a student, the full experience is $188.
Wow.
So
What?
my point to everybody here is look at professional venues, conferences, etc., and look at student pricing. I haven't been a student for 30 something years. So coming back to being a student is reaping unexpected rewards outside of the curriculum. So as we're all getting ready to get our, this accomplishment done, definitely be looking for that opportunity type thing as well. I'm sorry, I don't mean to market, but
No,
I
that's
keep
a great.
discovering
No,
things
that's
that are
amazing
great.
news.
Yeah, that's great to know. And they have UWF has some conferences too. Like there's a women's leadership conference. So Wendy, Jody Ann, that's like our wheelhouse, but that conference is also student discounted as well. So it's, something that we could always go to. And it's nice to get that huge discount for being a student, I just need it,
We love student discount.
Yeah.
I just want to figure out how to use my MBA and work from home.
I don't think that's going to be hard.
It's not going to be hard. I work from home right now. I mean, it's very,
do
very
too.
possible. Yep.
Yeah, I've loved being at home this last couple of years, going to school, and I'm like, I used to do regional management for retail, and I'm really past people at this point, so I just want to work in front of my computer with my dogs.
Yes.
Aw.
I think it's possible. I think that's going to become the way of work. I think that a lot of employers, I mean, I've been going into the office like once as needed, but I know that for the most part, a lot of our workforce is working from home, even the engineers. If they're
Yep.
not working in a skiff or anything like that, they're in the off, they're working from home. So I think
Yeah,
that's
a lot of
okay.
companies are migrating to a hybrid model.
Yes. Yeah.
One of my good friends works for Salesforce. He's been home for actually since before the pandemic.
Mhm.
And so, yeah, it's definitely, it's going on.
That's
Guys,
exactly where I
thanks
wanna
so
be.
much. This was super awesome.
I agree.
Yeah,
Very
thank
helpful.
you. And Shannon,
I agree.
beautiful Excel spreadsheet. Thank you.
Oh, thank you,
Shannon,
Wendy.
you
you
As
for
rock.
always,
sharing.
thank
Very,
you.
very
You're
much.
welcome.
Yes.
So I'm uploading
Very,
this
very
now.
much.
Stu, do you think we should email it? We don't need to, right? Or should we say something?
My feeling is if people are motivated, I'll
They'll go
email
on
out
there.
that there's a recording
And they'll hear it,
and
that we
they'll
uploaded.
hear it. Exactly.
Agreed.
I think that's fair.
I
I don't want to
agree.
give away the whole ship. And,
Yeah.
I do, right? But I want people to be diligent enough to know where to look. I don't want
Right.
to spoon feed it. We're in a master's level program. I feel
I
like I'm already doing that. Anyway,
So very good. This will be uploaded like in 2 minutes, doing it now.
you
All
guys have
Thank
a
you.
wonderful evening. Shannon, thanks so much. You just
Thank
uploaded it.
you.
It's there.
All right. You're welcome. Well, you guys have a great day. Bye, everyone.
Thanks,
Bye.
guys. Good luck on
Bye.
the
Bye, guys. Good night.
Good night.
Good night.